In this tutorial, we will look at how atoms form ions. To start with, let's define an ion. So an ion is a charged atom. So for example, you might see something like Na plus or Mg2 plus or O2 minus. So as long as you see a plus or a minus charge, that's an ion. So we can have two kinds, as I just mentioned, one with a positive charge, that would be a cation, and another might be or may have a negative charge, and that would be called an anion. So let's take our oxygen as an example. So if we take a look at the atomic number of oxygen, it means it has 8 protons, 8 neutrons. So the electron configuration is 2, 6. But to be stable, atoms want to have a complete outside shell. So although it has 6 on its outside shell, this is not complete. So in order to complete it, the oxygen will want to gain 2 electrons. And if it does that, instead of having 8 electrons, it now has a total of 10 electrons, therefore having 2 more negative charges than positive charges, because protons are positive and electrons are negative. So therefore the ion formed is O2 minus. Let's take a look at another example. So this time nitrogen. So nitrogen has an electron configuration of 2, 5. It has 7 protons and it has 7 electrons in a neutral atom, that is. But in order to have a complete outside shell of valence electrons, it would need to gain 3 electrons. So that would mean that it now has 10 electrons, so 10 negative charges, over 7 positive charges in terms of protons. So it has 3 more negative charges, and therefore you get N3 minus. Now let's have a look at some atoms that form positive ions or cations. So lithium here has an electron configuration of 2, 1. It has 3 electrons and 3 protons in a neutral atom. But in order for it to have a complete valence shell of electrons, it actually has to lose that 1 electron from the outside shell. Therefore, instead of having 3 electrons, the lithium now has only 2 electrons, and therefore has 2 negative charges against 3 positive charges. So there's 1 more positive charge. So that forms an ion that is Li1 plus, and because it's a 1 plus, we don't tend to write that, so we just say Li plus. Now it's really a matter of, is it easier to gain or to lose electrons in order to complete that valence shell, that outside shell of electrons? So in this case, now in our final example, we'll take a look at aluminum. So aluminum has an electron configuration of 2, 8, 3, 13 protons, 13 electrons in a neutral atom. Now it has 3 valence electrons. It's a lot easier to lose the 3 valence electrons than it is to try and go and find another 5 to fill out that third shell. So if you lose the 3, now you have a complete outside shell. That's the second shell. However, in doing so, you now, instead of having 13 electrons, you actually have only 10. So you have 3 more positive charges in the form of 3 protons than you have electrons. Therefore, you get Al3 plus as the ion. Now, if you look at the periodic table and you look at the group number that the element is in, you might think of it as a column, but we call it a group. The group number is equivalent to the number of electrons on the outside shell, or the valence electrons. Therefore, elements in a group form ions with the same charge. So in group 1, they would form 1 plus because they would lose the electron on the outside shell. Group 2, 2 plus, and 3, 3 plus. But in group 7, it would be a 1 minus because they would gain 1 extra electron in addition to the 7 that they already have. Group 6, 2 minus, group 5, 3 minus for the same reason. That leaves group 4. These tend to bond covalently and not so much in ionic bonding. And then those in the middle, the transition metals, well, some of them are capable of forming more than one kind of ion, and we can address that in another tutorial.